Okay, so in this particular video, we will be looking into quite an old residual current device, or as we refer to it locally, the salva vita. And we have seen previous videos where we have tested some modern RCDs. But this is an interesting artifact which was donated by a current client, and we have this particular model which is the Electrostop DS912. As we can see, as an RCD, it is quite a large device, and basically it looks like a main switch with a disconnection mechanism. The rating is at 60 amperes and it has a nominal tripping current of 30 milliamps. Now obviously, since this RCD is quite old, it was specifically designed to be used for AC leakage currents, which was the norm at the time it was available on the market. Today we know that due to power electronics we have different types of leakage currents, not all of which are AC, with the most common being the DC ripple type, for which we have the type A RCD. But it is interesting to test this RCD with different types of leakage currents, and in this video we'll be testing with AC and DC ripple leakage currents. Obviously I have to trick the RCD into generating a fault without switching all of my workshop, and therefore I have one wire connected at the output side on the line conductor, and on my input I have connected an earth wire which is connected to the neutral of my input side, so that the imbalance is only across this device, and therefore I do not have a tripping of the main RCD. So we have our instrument which is set up. Currently it is set up at 30 milliamps type AC. I will press the test button. I have to energize the system, so I am arming the RCD. Okay, we can see that we have the lightning symbol. It means that there is power detected across the instrument terminals. I press test and see what happens, and we get a tripping time of 21 milliamps, which is a reasonable value for the RCD, and we also get an RCD pass. Now the next step is that we are going to test for DC ripple current. I'm going to arm the system as before. I get the power on sign. I press test and wait to see what happens, and the instrument is telling me that up to 45 milliamps I am not getting an RCD trip. So I'm going to go into the next setting, which is 100 milliamps, and test again and wait a few moments to see what happens, and once again I have no trip even when there is a DC ripple current of 150 milliamps. So we can see that there is a significant difference in the performance of this RCD for type AC currents, which was for which it was originally designed and sold with respect to DC leakage currents. Obviously, at the time, no appliances consumed DC leakage currents, and therefore there was not the need for such a DC leakage currents. However, today we still find, especially in old properties which have not been renovated for some time, we still find this type of RCD, and as we can see, it practically has no protection for DC ripple leakage currents. I am going to continue testing. Now I am going to set the instrument to a variable leakage current. I am going to go to 200 milliamps. I press test, wait for some moments, and once again I do not get any trip. Let us try with the 300 milliamp setting. And now we finally get a trip for the DC ripple current for 390 milliamps, which is exceedingly high, and this provides no protection to the final circuits. Now, typically leakage currents are very complex waves, but due to the problem of having DC ripple or DC leakage currents, the RCDs may not function as desired. So through this simple video, we observe that there is a significant difference in performance for these old type RCDs, and it is highly recommended to convert such systems to modern type A RCDs. Obviously, the type A includes the safety protection for DC ripple currents, and the tripping times for these modern devices are in line with the regulations. Obviously, if we had to test, as we have done in previous videos, a 30 milliamp RCD with DC ripple, it would trip at a current which is less than the 30 milliamps, as opposed to what we have seen here. So check your consumer units, especially if you live in old properties, and if you have something which is similar to this electrostop, or even if it is slightly more modern RCD, it is highly recommended to change it, because the cost of the RCD is a few tens of euros compared, which is nothing compared to the safety benefits of such a device. We hope that you have enjoyed this video, and if you would like us to test more devices, please contact us through our Facebook page, KSC Engineering Malta.